Hello student, let's try to understand application of equilibrium constant. Right. So what are the role of equilibrium constant, student? First one, for the predicting extent of reaction, means how much reaction is completed, student, that is what is called extent of reaction. So let us try to see the extent of reaction means how much it is completed. The equilibrium constant Kc can be used to forecast the extent of reaction, that is degree to which the reactants disappear. Degree to which the reactant disappear, the value of equilibrium constant indicate the relative quantities of the reactants and product. What is the first point, student? First point, if Kc value is too large, student, so mainly it is what product is dominant. Let us read this slide. The higher the value of equilibrium constant, how much it is, the 10 power more than what is there, student? 3. 10 power more than 3. The more forward reaction is preferred. If it is more than 10 power 3, more forward reaction is preferred, indicating that the concentration of product is substantially higher than the reactant at equilibrium. What is meaning, student? Concentration of product is higher, higher than the concentration of reactant. This demonstrates that at equilibrium the concentration of the products is very high, indicating that the reaction is nearly complete. What are the example, student? H2 plus Br2, it is giving 2 HBr. Its value is 5.4 into 10 power 3. It is too large than the 10 power 3 according to the concept, student. The it indicate what, student? Mainly product is there. Mainly what is there, student? Mainly product. This is. Now we are going to understand the second point, student. The intermediate value of the equilibrium constant, that is 10 power minus 3 to 10 power 3, indicate that reactant and product concentration are equivalent as example. So both are going to be the same, like Kc is there, 138. Kc 138 means Kc is equal to, you can write, student, 1.38 into 10 power 2. So this is going to be between the 10 power 3 and 10 power minus 3. So that is product and reactant. Reactant and product concentration are equivalent. That is the equilibrium is there. Now third point, you see. A low value of equilibrium constant, that is 10 power minus 3, indicate that the backward reaction is favored. Okay, implying that concentration of reactant is significantly greater than that of product, implying that the reaction progresses to very minor extent in the forward direction. As example, N2 plus O2, it is giving 2NO. Here Kc value minus 10 power 31, student. It means here is the, this you see, this is very less value, student. So only reactants are there, no product will form, student, in this case. Now second heading we are going to understand what is the equilibrium constant for predicting the direction of reaction, student. Equilibrium constant for predicting the direction of reaction. How can you predict the direction of reaction, student? Okay, whether it will go forward direction or reverse. Now, the equilibrium constant can be used to forecast the reaction direction. We require a term called the reaction quotient, QC, in term of concentration of QP in term of partial pressure, which is identical to the equilibrium concept constant, except that the condition are not equilibrium. This is the condition are not equilibrium. So QC is not calculated on equilibrium, it can be any place. If it is the equilibrium condition, it will call Kc. Now A mole of A, B mole of B, C mole of C, it is giving D mole of D for the balance reply in comparison to Kc in term of the reaction direction. So see, the first point you see, first point important, what is the reaction is equilibrium if QC is equal to what is there, Kc, where Kc is equilibrium constant and Qc is equilibrium quotient. Now if Q is greater than Kc, Q is greater than Kc, so it will be backward reaction, student, reverse itself. Q will tend to decline until it equals K. As a result, the reaction will reverse itself. Next one, student, what is the next one? If Q less than Kc, Q will tend to increase until it equal to K. So if it is less, it is going to be equal to K. So as a result, the reaction will go forward. Okay. Ultimately, you have to be in the condition of equilibrium constant. We have to be in the equilibrium condition. Okay. So if suppose Q is what more than Kc, so it will go what direction, student? It has to decrease. It has to decrease. If it is decreasing, means backward. Backward. Okay. Suppose the another condition, Q is less than Kc, so it is what it should increase. It should increase. So it should increase. It should increase means what? It is going to be forward. And what is the QC is equal to Kc? This is the equilibrium condition. What is there, student? Equilibrium. So this is all about our required answer, student. Thank you very much for watching. If you find this video helpful, please do like and subscribe the channel.